Hi, I'm Patrick Reagan. Welcome to the TCP/IP series of videos. This video is called TCP/IP Part 1, the TCP/IP Suite in the Internet Protocol, which introduces the TCP/IP Protocol Suite and covers the lowest protocol of the TCP/IP Suite, the Internet Protocol, and its related protocols. It also discusses physical and logical addresses and how they are used to send packet from the source computer to the target computer. TCP/IP Protocol Suite is the de facto protocol used with the Internet in corporate networks. With the TCP/IP Protocol Suite, TCP/IP does not worry about how the host, computers, or other network connections connect to the network. Instead, TCP/IP was designed to operate over nearly any underlying local or wide area network. While the figure shows the early implementations of TCP/IP, today's LAN protocols include Ethernet and 802.11 Wi-Fi, and WAN protocols including Metro Ethernet. The lowest protocol within the TCP/IP suite is the Internet Protocol, or IP, which is primarily responsible for addressing and routing packets between hosts. A host is a computer or device that's running TCP/IP and that is assigned a unique logical IP address such as 192.168.5.243 or 50.233.23.17 that acts as a digital home address. It is called a logical address because the IP address is assigned to a device on a network, but it's not tied to the physical hardware like a MAC address, and it can be changed or reassigned by software or network configuration. IP breaks data into packets, ensures they're sent from the source to the destination. IP can break large packets into smaller fragments and reassemble them at the destination. IP also handles routing, which determines the best path for data to travel across interconnected networks, often via routers. IP is a connectionless protocol, which means that there's no established connection between the endpoints that are communicating. IP does not guarantee any deliveries. Packets can get lost, delivered out of sequence, or delayed. Instead, it must rely on TCP to determine that the data arrived successfully at its destination and to retransmit the data if it did not. When we access resources, we like to use names because they're easier to remember. Name resolution is provided by DNS servers that translates from logical names to IP address or logical address. However, the underlying protocols communicate based on the hardware address based on the physical addresses called MAC addresses, which is assigned to the network interface, such as your Ethernet interfaces or Wi-Fi network interfaces. The Address Resolution Protocol, or ARP, translates from the logical address to the physical address. RIP and OSPF are examples of two routing protocols that help smooth packets between different networks. BGP is another routing protocol worth mentioning that is the primary routing protocol used on the Internet. When a packet reaches a router, the router will determine the next step that gets the packets closer to its destination and forward the packets toward that direction. The Internet Group Management Protocol, or ICMP, is used for multicasting, which enables a group of network devices to share the same IP address and receive the same messages. Remember, multicast is a network communications method that a single source sends data to a group of receivers simultaneously using one set of packets. The IP header contains essential information for routing and delivery, such as source and destination IP addresses, the version, the header length, total length, time to live or TTL, the protocol, and checksum. The version indicates IP version, either being IP version 4 or IP version 6. The header length specifies the length of the IP header. Time to live, or TTL, limits the packet lifetime to prevent infinite looping. Protocol identifies the encapsulated protocol such as TCP or UDP. Checksum is used for error checking of the header. And the payload contains the data being transported, such as the TCP segment or a UDP datagram. Let's take a look at how a packet is sent from a computer to a server. Step 1. DNS lookup is optional but typical. Your laptop asks the DNS server for the IP address of www.example.com and gets back 93.184.216.34. Step 2. Your computer prepares a packet. Source IP 40.32.54.230, which is your laptop's IP, and the destination IP will be 93.184.216.34, which is the web server. Step 3. Before your laptop can send the packet to your home router, it must find the MAC address of the router or default gateway, which is the local address to the client's network. It sends an ARP request who has 40.32.54.1. The router responds with its MAC address of AA:BB:CC:CD:DE:FF. Step 4. Your computer creates a layer 2 frame by wrapping an IP packet in an Ethernet frame. Source MAC, your laptop's MAC address of 11:22:33:44:55:66, and a destination MAC address, which is the router's MAC address of AA:BB:CC:CD:DE:FF. This frame is sent over the LAN. Step 5. The router processes the packet by stripping the Ethernet frame, seeing the destination IP is outside of the local network, and forward it toward the ISP using the new Ethernet frame with new MAC address. Step 6. The router will forward the packet to the next router that gets it one step closer to its destination based on the IP address of 93.184.216.34. Routers across the internet use only the IP address to forward the packet closer to its destination. Each time it reaches a router, it will ask, which way do I go? At each hop, the MAC address changes, but the IP addresses stay the same. Step 7. The server at 93.184.216.34 receives the packet. When the server responds, it will send back a response using its source IP address of 93.184.216.34 and the destination of 40.32.54.230. Step 8. The returned packets travel back across the internet, eventually reaches your router, and uses ARP to find your laptop's MAC address where the packet is delivered. To summarize how addresses were used, Layer 3, the IP or logical address, was used for overall source and destination IP address and routing between the networks. Layer 2, or MAC or physical address, was the local delivery within a network. While the packets are basically delivered based on MAC addresses, besides the router determining which way to go to forward that packet, it is the device that moves the packet from network to another network. Essentially, the packet will enter one IP address and will exit an IP address, which could be the same address or a different address based on what is the best way to get to its destination. The Internet Control Message Protocol, or ICMP, is a crucial component of the Internet Protocol Suite used for network diagnostic, error reporting, and operational queries. ICMP is primarily used by network devices like routers and firewalls to send error messages and operational information to indicate issues with data transmission. When you use the ping and traceroute commands, you're using ICMP packets to assess connectivity, latency, and routing information. Question: what is the primary protocol suite used on the Internet? Answer: TCP/IP. Question: which address is the logical address used in the TCP/IP suite that are signed to a host? Answer: IP address. Question: Which address is assigned to a hardware interface and does not change? Answer: MAC address or physical address. Question: What protocol is used to generate data that is shown with the ping and trace route commands? Answer: ICMP. Question: What protocol is used for network diagnostic, error reporting, and operational queries that are mostly used by routers and firewalls? Answer: ICMP. Question: What protocol is responsible for delivery of packets between a source and host computer? Answer: IP. Question: What protocol is responsible for resolving IP address to MAC address? Answer: ARP. For more information, visit these sites. In summary, TCP/IP protocol suite is the de facto protocol used with the internet and corporate networks. The lowest protocol within the TCP/IP suite is the Internet Protocol, which is primarily responsible for addressing and routing packets between hosts. A host is a computer or device that's running TCP/IP and that is assigned a unique logical IP address. The IP address is a logical address because the IP address is assigned to a device on a network, but is not tied to the physical hardware like a MAC address, and it can be changed or reassigned by software or network configuration. The IP address is used for overall source and destination IP address and routing between networks. The physical address or MAC address that is tied to a physical network interface and is used for local delivery within a network. Thank you for watching this video. The next video will be TCP/IP Part 2, TCP, UDP, and ports. If you have not already, subscribe to the Pat Hatcher back channel. Thank you.